Welcome. So what we're going to do is I'm going to show you how to solve by graphing this linear system. Now, so far we worked on ones that have been fairly easy to graph, right? Y equals 4x plus 3. We can graph that because we know our y-intercept is going to be 3 and our slope is going to be 4. So by using our slope-intercept form, we can go ahead and graph that first equation. Now, the second equation usually is what's going to give a lot of students the trouble. So I'm going to go through that one separately. But the first thing is let's graph this first equation just so we can kind of see it, because I'm going to spend some time working on the second equation. So remember this first equation, my y-intercept is at 0, 3, right? Because the coordinate point of your y-intercept is going to be 0, 3, even though the value for b is 3. So I go up to 3, right? So it's 0, 3 is your coordinate point. Then I convert my slope to a fraction. So therefore, I can determine the rise over the run. And it tells me to go up 4, 1, 2, 3, 4 over 1. All right? Or I could also go in the opposite direction, down 4 to the left 1. All right? Then I connect these points. OK. So now let's go and get to this next equation. So I have 20x minus 5y equals negative 15. All right, so when dealing with an equation like this, there's a couple different methods that we talked about. One was we could graph by using the x and y intercepts. We could also graph by converting to slope-intercept form, and that's what I'm going to do in this example. So I have y equals mx plus b. And what I want to do is I want to take this equation and convert it to this format, the y equals mx plus b form. So that means what I need to do is I need to isolate this y variable. And to do that, I need to use my inverse operation. So I need to undo the operations that's being applied to my variable. So first thing we always do is undo addition and subtraction. And what we notice is that this y is being added by a 20x. If I was to rewrite this, this is a positive 20x. So the 20x is actually being added to this y. So I'm going to subtract 20x. Therefore, I have a negative 5y, because 20x minus 20x goes to 0x. So I have a negative 5y equals negative 15 minus 20x. Now, this gets a lot of students confused, is I don't want to write the 15 in front of the negative 20x. I want to write mx plus b. So I'm going to rearrange this to negative 20x minus 15. Now, I need to undo what the last part that's happening to my variable y, which is it's being multiplied by negative 5. So to undo that, I need to divide by negative 5. Therefore, I get y equals, now this negative 5 has to divide into both of these terms, right? It's an equation, so you have to make sure you do it to everything on that side. So negative 20 divided by negative 4 is a positive 4x. Negative 15 divided by 5 is going to be a positive 3. Which is very, very, very interesting, because what we notice, ladies and gentlemen, is this is the exact same equation as our other variable. Therefore, if I was to graph this, I would have the exact same line. So therefore, our number of solutions is the intersection is infinite, right? They intersect at that point, and every single other point on this line. So there's not just one solution to this systems of equations, because really they're the exact same line. So they have infinite many intersection points. So therefore, the solution, we say it's infinite many. All right. So since we do have a solution, it is consistent. However, since there is more than one solution, so it is consistent because we do have a solution. But now, since there is more than one intersection point, or more than one solution, our solution is what we call dependent. So there we go, ladies and gentlemen. That is how you graph and solve a system of equations with infinite many solutions. Thanks.